Namaste, my friend, and welcome back to JEE Mathematics with Typical Mug. This is class 8, and today we step into trigonometry properly, ratios and identities. Here is something worth sitting with for a moment. Every angle you will ever measure, every wave you will ever graph, and a good half of the equations JEE will ever hand you all rest quietly on three simple ratios traced around one circle of radius 1. When David first met that circle, he tried to memorize every sign in every quadrant as a separate fact. One by one, there is a better way. See the picture clearly, just once, and every sign, every identity, derives itself from that picture forever after. Today, one idea at a time, we build that picture together. Take a slow breath. Let us begin. So what will you carry home from today's class? First, angle measure, degrees and radians, and moving cleanly between the two. Second, the trig ratios themselves. Read straight off the unit circle and their sign in each of the four quadrants. Third, the fundamental and Pythagorean identities that tie sine, cosine, and tangent together. Fourth, compound angles, double and multiple angles, and the sum to product transformations. And fifth, the JEE drills, a worked identity, a match, and a short answer round, so everything you learn today, you can also score with. Ready? One idea at a time. Let us start with the raw material, how we measure an angle, and how we read a ratio of a circle. One full turn is 360 degrees, and it is also 2 pi radians, so 180 degrees equals pi radians. Exactly. Keep that one equivalence, and every conversion follows. Now, picture a circle of radius 1, centered at the origin. For an angle theta measured from the positive x-axis, cosine theta is simply the x-coordinate of the point where the angle meets the circle, and sine theta is the y-coordinate. Tangent theta is sine theta divided by cosine theta. Secant, cosecant, and cotangent are nothing new. They are simply the three reciprocals of cosine, sine, and tangent in turn. And learn the 5 standard angles called 0, 30, 45, 60, and 90 degrees. Almost every JEE numerical leans on one of these 5, so they must be instant, not calculated. Now look at this circle, because it turns every sine rule into a single picture. A point moves around the circle as the angle grows, and its coordinates are exactly cosine theta and sine theta. In quadrant 1, from 0 to 90 degrees, sine, cosine, and tangent are all positive. This is the friendly quadrant, the one everyone starts from. In quadrant 2, from 90 to 180 degrees, only sine stays positive, cosine and tangent both turn negative. In quadrant 3, from 180 to 270 degrees, only tangent turns positive, sine and cosine are both negative there. And in quadrant 4, from 270 to 360 degrees, only cosine turns positive. Say the 4 words in order: all, sine, tangent, cosine. One for each quadrant, and the sign of every ratio falls out instantly, without a single doubt. Now, the family of identities that ties everything together. The master identity, sine squared theta plus cosine squared theta equals 1. It comes straight from the circle we just drew, because every point on it sits at distance 1 from the center, and that distance, by Pythagoras, is exactly sine squared plus cosine squared. Divide that master identity through by cosine squared theta, and you get 1 plus tangent squared theta equals secant squared theta. Divide it instead by sine squared theta, and you get 1 plus cotangent squared theta equals cosecant squared theta. And 2 symmetry rules worth knowing called sine of minus theta equals minus sine theta, which makes sine an odd function. Cosine of minus theta equals cosine theta, which makes cosine an even function. Time to prove a full identity together slowly, the monk's way. Prove that 1 minus cosine 2 theta divided by 1 plus cosine 2 theta equals tangent squared theta. Step 1. Write down exactly what must be proved. 1 minus cosine 2 theta over 1 plus cosine 2 theta should simplify to tangent squared theta. Step 2. Handle the numerator using a double angle form. 1 minus cosine 2 theta equals 2 sine squared theta. Step 3. Handle the denominator using the other double angle form. 1 plus cosine 2 theta equals 2 cosine squared theta. Step 4. Substitute both back into the ratio. It becomes 2 sine squared theta over 2 cosine squared theta, and the 2's cancel cleanly, leaving sine squared theta over cosine squared theta. Step 5. Conclude. Sine divided by cosine is tangent. So this is tangent squared theta, exactly what we set out to prove. Notice the path: numerator, denominator, substitute, conclude. The same double angle forms unlock most identity questions JEE can ask. Now the heart of the chapter, where the double angle formulas actually come from. Look at this panel of 4 formula cards. First, the compound angle formula for sine. Sine of a plus or minus b equals sine a cosine b, plus or minus cosine a sine b. Second, the compound angle formula for cosine. Cosine of a plus or minus b equals cosine a cosine b, minus a plus sine a sine b. Notice how the sign flips compared with sine. Third, and this is the key move, set b equal to a. That single substitution is exactly how the double angle formulas are born. They are not a separate fact to memorize. And 4, the result, sine 2 equals 2, sine a cosine a, and cosine 2, a equivalent faces cosine squared or minus sine squared a, or twice cosine squared or minus 1, or 1 minus twice sine squared a. Pick whichever face matches the question in front of you. Now sit up straight. These 5 lines are what JEE actually asks year after year. 1. Derive the sign pattern of sine of a plus or minus b and cosine of a plus or minus b from the compound angle formula itself, rather than memorizing 4 separate patterns. 2. Cosine 2 has 3 faces: cosine squared, a minus sine squared, a twice cosine squared, a minus 1, and 1 minus twice sine squared a. The question in front of you tells you which face to use. 3. Sum to product turns an addition into a multiplication, which is exactly what most trig equations need before they can be solved. 4. Keep the standard angle values instant: 0, 30, 45, 60, 90 degrees, and for the advanced level, 15 and 75 degrees too. 5. Never assume a sign. Always check which quadrant the angle lands in first, and only then read the sign of that quadrant. Let us drill the JEE way. I read a claim, you decide true or false, and if it is false, find exactly where the reasoning breaks. First claim, sine of a plus b equals sine a plus sine b. Let us check. Sine does not distribute over addition the way a straight line would. It must be expanded through the compound angle formula. So this is false. The correct expansion is sine a cosine b plus cosine a sine b. Second claim, cosine 2 theta equals 2 cosine theta minus 1. Think carefully. The correct double angle form squares the cosine. It does not merely double it. So this is false. The correct form is 2 cosine squared theta minus 1. Third claim, tangent of 135 degrees is negative. Check the quadrant. 135 degrees sits in the second quadrant, where only sine stays positive. This one is true. Tangent is indeed negative there. A quick match now. Say each simplified value aloud before I reveal it. Sine squared theta plus cosine squared theta. This simplifies to 1, the master Pythagorean identity. 1 plus tangent squared theta. This simplifies to secant squared theta, dividing the master identity by cosine squared theta. 2 sine, a cosine, a. This simplifies to sine 2a, straight from the double angle formula. And cosine squared theta minus sine squared theta. This simplifies to cosine 2 theta, one of its 3 equivalent faces. If all 4 came to you before the reveal, the identities are becoming yours. Here is a favorite JEE format. I read some statements. You silently count how many are correct. Statement 1. Sine of 90 degrees plus theta equals cosine theta. Hold your verdict. Statement 2. Cosine of 180 degrees minus theta equals cosine theta. Think before you answer. Statement. 3. Tangent theta equals sine theta divided by cosine theta whenever cosine theta is not 0. So how many are correct? 2 statements, the first and the third. The first is a genuine complementary angle result, and the third is simply the definition of tangent. But the second one false. Cosine of 180 degrees minus theta actually equals minus cosine theta, not cosine theta, because 180 degrees minus theta sits in a quadrant where cosine turns negative. 2 correct statements 1 and 3. Now let me save you some marks. 2 myths that trap thousands of students every year. Myth 1. Sine of a plus b equals sine of plus sine b. It feels natural. Surely sine behaves like a straight line and spreads across the addition? Lisa believed this for weeks. But here is the truth. Sine does not distribute over a sum at all. The correct expansion is sine a cosine b plus cosine a sine b. Always 4 terms before anything simplifies. Myth 2. Every trig ratio is positive in every quadrant. Surely a ratio is just a ratio, sine and all. The truth, sine strictly followed the quadrant rule. All 3 are positive only in the first quadrant, only sine survives in the second, only tangent survives in the third, only cosine survives in the fourth. Check the quadrant every single time. Time to test yourself, rapid fire. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just the ideas you built today. Question 1. What is the value of sine 30 degrees? 1/2. Question 2. Sine square theta plus cosine square theta equals what? 1. Always. Question 3. Write cosine 2 theta using sine theta alone. 1 minus twice sine square theta. Question 4. What is the sine of tangent theta in the third quadrant? Positive. And question 5. 180 degrees equals how many radians? Pi radians, exactly. If you caught all 5, you have truly understood today's class. Let us gather the whole class in one slow breath. 180 degrees equals pi radians, and on the unit circle, cosine theta is the x-coordinate. Sine theta is the y-coordinate. Sines follow the 4 words. All, sine, tangent, cosine, one positive ratio family for each quadrant in turn. The Pythagorean family ties the ratios together. Sine squared plus cosine squared equals 1, and its 2 divided forms with secant squared and cosecant squared. Compound angle formulas give sine and cosine of a sum or a difference, and setting b equal to a produces every double angle formula you will ever need. Cosine 2 wears 3 faces, and sum to product turns an addition into a multiplication before you simplify or solve. And next class, we step into trigonometric equations, general solutions, and exactly how to count them inside a given interval. Do not miss it. And so, my friend, we have taken a giant step today. It may have looked like just one circle and a handful of formulas, but understand this. Every identity you met today and everyone you will ever meet later is built from that one circle and the compound angle formula. Sarah, David, Lisa, and John all once tried to memorize these as separate facts. You now know they all come from one picture. Be patient with yourself. Tonight, revise the double angle forms of cosine 2a once, slowly, until all 3 faces feel like one idea. One idea at a time, you will crack G. Of this I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you in the next equation.